Hello and welcome to today's class. We are going to handle area and a curve, of course. Yeah. So we all know how to find the area. Let's say of a rectangle, length times width, area of a square, length squared. All right. Area of a triangle, half BH, half base times height. But can you find the area of a curve? So that is what we area under a curve basically, not a curve, area under a curve. So that is what we're going to basically tackle and for the rest of this video. So the question, the problem: find the exact area enclosed by the curve y equals to x squared, the x-axis, the line x equals to 2 and x equals to 4. Let us maybe look at what this actually mean for us diagrammatically. Then it becomes easier for you to then go ahead and look at it. Okay, to understand what the question actually is asking from us, let us look at this diagram here. Okay, so we are having the Cartesian plane. This is the y-axis and this is the x-axis. All right, then we are having a curve here. All right, so this curve here, which actually you can see here, as labeled to be y equals to x squared, is the curve we were talking about in the question. So we are supposed to find the area under the curve y equals to x squared, of course, demarcated by the x-axis, okay, and these two lines, and that is a line x equals to 2 and x equals to 4. So this shaded region here is the area that we are supposed to find, and we are going to use integration to go ahead and solve this particular problem. All right, so why don't we dive in, and then now that you have the graphical view of it, why don't we dive in and then give it a go. All right, so you've seen the graphical view of it, and so we are going to then go ahead and solve that problem. That is, find the area of that shaded region that was clearly demarcated by the lines x2, x4, and the x-axis, of course, all of it below y equals to x squared. So for us to find that area, we are basically going to find the integration of y equals to x cubed. All right, so we're going to find the integration of this, that is the integration of the equation of the curve that we were talking about there, that is y equals to. So we're going to find the integration of x squared. All right, so y equals to x squared is the equation or the expression that is actually describing the curve that we were talking about there. All right, so we are going to have it as the integration of x squared, as that is what the value of y is, of course, with respect to x. Okay, so we're going to integrate x squared with respect to x, and while doing that, we are going to do it using limits. So this is going to be a definite integration. So we're going to do that taking into consideration the values of x1 and x2, the lower value of x and the higher value of x. That is going to be x2 as the lower value here, and x equals to 4 as the higher value. So by integrating this, we will have found the area of the shaded region that we had earlier on seen in the graph. All right, so why don't you go ahead and integrate this particular problem and then see what we're actually talking about. All right, so this here is going to be, so x plus 1, the x index plus 1, that's going to be 2 plus 1, it's going to be 3, all over 3, okay? And because in this particular case, we are dealing with a definite, we're dealing with the definite integral problem, we won't add the constant. So we're just going to have it like that, and then we are going to show the limits on the right-hand side, as you are seeing in that particular problem. And so for us to find the exact area, we will subtract, okay, the values of x with the upper limit minus the values of x with the lower limit, that is 2. So that's going to look something like, so wherever we have x, we're going to input the upper limit. So the upper limit in this particular case happens to be 4. So it's going to be 4 cubed, okay, all over 3, okay, minus, okay, so wherever we have, because that's it for the upper limit. So we're going to subtract the lower limit. So wherever we have x, we're going to put the lower limit. So basically that's going to be 2 cubed all over 3. And so when you do this in your calculator, notice that you find, notice that you are going to find 18 and 2 all over 3 square units, okay, square, as this is area, so we were supposed to find the exact area, so this is going to be square units, okay, square units. So basically what that means is that the shaded region below the curve that was actually demarcated by x2, x4, and the x-axis under the curve y equals to x squared is actually given to be 18 and 2/3 square units. Let us handle a second example, then see how we can tackle even other variable problems under this particular topic of area under a curve. Okay, so for our second example, we are supposed to find the area of the region bounded by the curve y equals x cubed minus 3x squared plus 2x. The x-axis, okay, x equals to 1 and x equals to 2. Maybe if I just show you a graphical view of what we are actually talking about, then it makes sense to you. Okay, so basically what that problem is asking us to find is this shaded region here, okay? You see this shaded region of the under this curve? That is the area that we're being told to find. So basically it is the area that has been bounded by the curve y equals to x cubed minus 3x squared plus 2x. So that is the curve, and it has been bounded by the points x equals to 1 and x equals to 2. And I want you to notice that this particular shaded region is under the x-axis. This is the y-axis and this is the x-axis. So usually when we are dealing with problems where the shaded region is actually under the x-axis, the answer we get when we're doing our integral problem usually comes out to a negative number. Basically, that is to mean that the shaded region is below the x-axis. So don't be surprised when you find a negative answer after your integration. Basically means that the shaded region that we are talking about is actually below the x-axis. Okay, if it's positive, then we're talking of the area that is actually above the x-axis. So this particular shaded region would give a positive integral answer, and this one here, because it's below the x-axis, will give us a negative answer. So I'm letting you know that so that you are prepared mentally before we go in and dive into the problem and now try and solve it. Of course, we are going to solve this particular problem using definite integrals again. Of course, our upper and lower limits are going to be 1 and 2. All right. Our upper and lower limits are going to be 1 and 2. And I'm also going to help you see the importance of knowing the roots of the problem that you're dealing with before you actually go ahead and solve problems that involves area under a curve. All right, let's go ahead and dive into it. Awesome. So before you solve problems that involves area or shaded or bounded regions by under a curve, okay, it's always important to first know the roots that would be gotten out of solving that particular quadratic or polynomial. All right. Okay. So in this particular case, when you look at y equals to x cubed minus 3x plus 2x, then you'd actually find that the roots to this particular problem, this curve alone, the areas under the places of intersection with the x-axis are actually, so you'd want to take into consideration the roots. So the areas of intersection with the x-axis are actually, for x1 we give it 0. Okay, for x2 we give it 1, and for x3 we give it 2. Okay. All right, so for x3, all right. So these here are the roots of this particular problem, okay? That is y equals to x cubed minus 3x squared plus 2x. And of course, plus x. As you had already seen in the diagram, let me show you again so that you see these particular roots. Yes, as I was saying, you can clearly see the roots, okay? So you can see 0 here, okay? It's the place of intersection between the curve and the x-axis. So this is our x1. Our x2 is actually, you can see, is here 1, and our x3 is actually 2. So those are the points of intersection with the curve. It is important to know the points of intersection. Why? Because then you are able to know if your limit is within range, your lower and your upper limit. If it's within range, then you know what you are actually dealing with, and you have a clear graphical view of the problem that you're trying to solve. Now, looking at these three roots, we can clearly tell that our limits are within range. We've been told to solve for the area bounded between x1 and x2. So it is within range. So we are not going to be worried. There's nothing outside of range here. So basically, we will focus on, all right, solving, integrating y dx, of course, with the limits 1 and 2. All right, so to solve this particular problem, we are going to find the definite integration of y dx, of course, that is the equation y with respect to x, with the limits that have been given here, 1 and 2. Remember, we're supposed to find the area of the region bounded by the curve y, the x-axis, x1 and x2. So these x1 and x2, these are our upper and lower limits. So our lower limit here, clearly you can see, is going to be 1, and the upper limit is going to be 2. Of course, this then translates to, of course, this is 1, this is 2. The value of y happens to be x cubed, okay, minus 3x squared plus 2x. All right, with respect to x. So we're supposed to integrate, that is x cubed minus 3x squared plus 2x with respect to x, of course, with the limits 1 and 2. And so when you do this particular problem, notice that you are going to have, okay, so let's start by integrating x cubed, okay? So when you add 1 to 3, we're going to get 4. So basically that's going to be x raised to 4 all over 4 minus, okay, so when you add 1 to 2 here, you're going to get 3, okay? So but that's going to be negative 3x cubed divided by 3, okay? So when you divide 3 by this coefficient, 3 divided by 3, you're going to get 1, and so you're going to have x being equal to, you're going to have x being integrated to x cubed, okay? Negative x cubed, as in the 3, the power has divided the 3 here, and so we no longer have 3 there, we are having 1 as our coefficient. And for 2x, we are going to have the same thing. So it's going to be x raised to 1. 1 plus 1 is 2. 2 divided by 2 is going to be 1. And so that's going to be plus x squared, okay, plus x squared. And this being a definite integral process, we won't add our constant. So we'll just close our parenthesis there and show the limits of this particular problem, which actually happen to be 1 and 2. Okay, so for us to then go ahead and find the area of the shaded of the bounded region, we are going to have the upper limit substituted into the equation minus the lower limit. So basically, that's going to give us the area being okay. So that's going to be 2. Anywhere we see x, we're going to put 2. All right, so it's going to be 2 raised to 4 minus 4. All over 4, I mean, okay, minus, so in here we're going to have 2 as the upper limit, so it's going to be minus 2 raised to 3, of course, plus x squared is 2, okay, so it's going to be 2 squared, okay. So notice that anywhere, any place we had x, I replaced that x with 2. That is the upper limit. So it's 2 raised to 4 all over 4 minus 2 raised to 3 plus 2 raised to 2 minus the lower limit, of course, wherever we have x now, we're going to put 1. So that's going to give us x, that is 1 raised to 4, which is 1 all over 4, minus 1 raised to 3, which is basically 1, plus 1 raised to 2, which is basically 1. Okay, so the difference of these two is what is going to give us the area. Okay, the difference of these two is what is going to give us the area. And so the area of this particular shaded bounded region that I had shown you earlier in the diagram is going to be given by in your calculator. You can key this in and find. Okay, so from a calculator, you will find the difference of these two to be equal to negative a quarter, So remember what I said. When you find a negative, basically that means that the area of the shaded region is below the x-axis. Okay, the area of the shaded region is below the x-axis. Let me just show you that in diagram. So basically that means that this shaded region is below the x-axis, and you can see clearly our x-axis and the shaded region is actually below it. So the negative sign should not be of any worry to you, as that simply means that, okay, all right, so we are just basically going to take the absolute value of negative a quarter, of course, and the absolute value of negative a quarter, of course, is going to be a quarter. So the area of this particular curve, shaded region, is going to be a quarter square units. Yes, so the absolute value of negative a quarter, so we're going to have its absolute value, which is going to give us a quarter square units as the area of the shaded region of the curve y x cubed minus 3x plus 2x bounded between x-axis x1 and x2. Let's handle another example maybe and see where it goes, as this topic can involve a lot of thinking and all that. So I have 2 more examples that are kind of technical, and I think it will be important that I postpone them to the next video, so that I do not have so much in one class. Let us do that in the next video, and maybe see you in the next class, and have a good one.